Good morning. We reached to the last lecture, and we speak a case study about the application of the membranes. Most of application discussed in the previous lectures, and most we repeat them and remind you. We know that in the recent decades, one of the biggest problems of the humans are problems of the environmental, because the population of the Earth now is more than 8 billion people, and India is the biggest one in the world. And as presented in this drawing, the Earth now is illness, and producing of the many pollutants from human activities, both in gas and both in the water, as well as in soil, cause to the many diseases, unknown diseases in humans. For example, microplastics, antibiotics. We use the antibiotics for our diseases, but now we know that the antibiotic can be dangerous for human and others. It is a big role, and say that everything that the human is produced is toxic. Everything that human is produced is toxic and dangerous. Therefore, because in production of many of the foods, we use the chemicals, and the using of chemicals is problems. I have want to show some problems as a caricature, and you see when we cut the trees, the life of most animals, as well as human. Human is animal also. The restriction of the water and water crisis is very important in many countries, especially in Iran. Iran has very, very crisis state about the water. With the beginning of the cities, we must to remove the jungles, forests, and many other problems. The weather problems, you know, the Delhi is the very bad air in the world, and there are many problems. We can, as an environmental science or as an environmental friendly persons, we must, with use of the science, cause the growing the environmental, and we must treat the pollutants from the air, soil, and weather for greening the life. Therefore, one of the techniques that can be help to this environmental pollution removal can be membrane, because membrane is a separation process, and we can, with use of suitable membrane processes, can remove these pollutants from the environment. About the water, we know that only 1% of the water in the world can be directly drink. 97% of water in Earth is saline, because it's located in ocean and seas, and we cannot use them directly, and we must remove the salinity, remove the pollutants, and after that use. And this cleaning is need many energies, and production of energy is also pollute the weather and the earth. Therefore, the first step for the environmental protection is low using. We must low use the chemicals, the cloths. In the 100 years ago, when we buy a cloth, we put them 10 years. But now we change every day a new cloth, and this is the problems, and other samples we can say. That means the lifestyle of the human is changed, and this is the main problems of the world. As a case study of the most used membrane process in the water and waste treatment water is membrane bioreactor. There are maybe 1,000 MBR plant in the world. Very, very usual and very, very simple method. We have an active slots system as a traditional one, and in this 40 years, for reduction of the biological tank reactor volume, the UF and MF membranes is used for separation of microorganisms. We before discussed that most use hollow fiber membranes, most use immersed one, not external one, and we use the aeration for reducing of the fouling, and the usual MBR unit similar to this one. We first have a particle strainer. That means we use filters. And after that, go to the biological system. Maybe first step can be anaerobic, and second step can be aerobic biological system. And for separation of microorganisms, the MBR is used. And with suction of this treated water, we have a treated water that can be used for agriculture. Most of the treated water from the wastewater usually used in agricultural use, and this can be also a problem because the removal is not complete, and the microorganisms cannot degrade aromatic materials, and this can cause to the going of the pollutant to the body of the fruits, vegetables, and we eat them. Therefore, we reduce the pollution, but when we use in agriculture, maybe have some problems. Therefore, it is better we use, after the MBR, advanced oxidation processes, AOPs, that in these systems, with use of UV H2O2, photocatalyst, phenton, electrophenton, and other radical production process, we can remove completely the all of pollutants. In the new systems, after MBR, usually use the AOP processes for complete removal. This is an example of the use of the MBR system in Lancaster City. Another systems that, as I say, use the UV after MBR. UV for complete removal is fabricated in Canada with capacity of 12 mgd million gallons per day. A big one, relatively, and have two steps of the MBR system in calculation of the volume for CSTR, continuous started tank reactors. Usually with dividing of one reactor to two reactors, the efficiency can be improved, as you learn in the reactor lesson. Therefore, in this system, use two parallel, two series reactors for increasing of the efficiency, and after treatment, use the UV for the second step, okay? Because here the concentration is higher. UF in the MBR, the UF and MF is used for separation of microorganisms. In most cases, about the use, we can use UF for water purification, not wastewater. We know water is different from wastewater, okay? Water purification, that means in this factory, in this Kamloops in Canada, use the hollow fiber UF for treating of the UF, drinking water, and the aim is the removal of bacteria, disinfection. And if there are some impurity, such as turbidity, and some of heavy metals. If there are some heavy metals, tight UFs, tight. We have two types of UF, loose, tight. That molecular weight cutoff can be different. In this case, use the hollow fiber UF for purifying of the water purification. The hollow fiber is used and is the similar the photograph of these systems. And this is the pumps that used. For this process, two parallel UF is used. Primary UF, about 100 Dalton, 100,000 Dalton, and secondary is 50,000 Dalton molecular weight cutoff. And after the final, use the activated carbon. Why use the activated carbon after UF? Why use activated carbon? What is the role of the activated carbon filter? Which? Exhaustment? Adsorption. Adsorption of the organic pollutant. Some little small organic pollutant cannot be removed by UF. And after UF, use this activated carbon filter for adsorption of the small of the molecules, and also activated carbon can be adsorbed the iron. Can adsorb the low amount of heavy metals. Therefore, it can be used. Another process is nanofiltration. Nanofiltration application is lower than MF, UF, and RO, because nanofiltration process is a new one. Nanofiltration suggested in 1909 years, and it is the new one. but now have a good progress. And the most application of nanofiltration in industry is the removal of hardness, removal of calcium and magnesium from the drinking water in most industrial water treatment plants. Now, for drinking water, we usually use the river and the well water. River water have good quality, and the hardness is low. But well waters, due to the contact with the stones, have high hardness. Therefore, in the most water supplying companies, use the well water, and for removing of the hardness, calcium, magnesium, usually use the nanofiltration because the concentration of the NaCl in well water is very low, okay? But we use for seawater directly RO. In this case, because NaCl concentration is low, usually use NF membranes that have higher flux and need lower pressure and lower energy. But the most application is hardness removal that in many Europe countries, this process is routine used. The second is the wastewater treatment. In many countries, use the NF. I checked the internet and see that in India, in textile industries, there are more than 10 nanofiltration units can used mostly for concentration of the dyes. Concentration of the dyes. After dyeing the textile, the concentration of dye reduce because absorb on the cloths, on the fabric. But we have a very, very color solution. Go to the NF, the water is separate, and the dye concentrated, and go back to the textiling or dyeing reactor. Another application of NF is in food and beverage industry. In producing of the cola, Fanta, usually remove the hardness for water and next add the cola materials. In all of the beverage industry, there is a hardness removal plant. In some cases use RO, in some cases use nanofiltration. Our NF can be used in the concentration of milk, whey, or better we say that in fractionation of the milk or fractionation of the protein. In milk, we have different type of the proteins that can be separated with a mix of MF, UF, and NF. NF can be reject the sugar. We can use for separation of sugar from the water and other application, or in some case clarifying fruit juice. Clarify the fruit juice. One application is pharmaceutical industry. We know that the most of the drugs are organic chemicals with molecular weight of about 300, 200 to 1,000 Dalton. The antibiotics and other drugs are mostly aromatic materials, aromatic organic materials with molecular weight of 200 to 1,000. And this molecular weight is good for nanofiltration separation. UF cannot separate, and usually use the nanofiltration for concentration, in some cases concentration, purification of the drugs. And in production line of the drugs, use this nanofiltration for purification and concentration. Most of drugs in the fabrication, in the synthesizers section, we want trans. We know that the trans form of this drug is good as a drug, and cis is not good. And separation of the cis from trans in the drugs cause to the high expense, high cost of the drugs. The synthesizer is simple, but separation need many money, many cost, because the separation of the isomers is very hard, and the need for distillation in vacuum distillation, because for organic compounds, the heat is not good, and we cannot heating in high temperature. Therefore, use the vacuum distillation, or use the nanofiltration or RO for fractionation and separation. Therefore, the most cost of the drugs is related to the separation process. But if we have a good catalyst that can only produce trans one, not cis one, this causes to the reduction of the cost and reduction of the drug money. Therefore, the development of catalysts in the synthesizers of the organic material is very important. And NF can be used in desalination. In some cases that we have a low desalinity, we can use the nanofiltration because need low energy, and mostly used for brackish water. The case study sample in this valley use the NF for natural organic matter removal, and previous the NF used a pretreatment of the microfiltration. The usual use, I say, for the softening, that for removal of hardness. And in most industries use this design for removal of the both desalination and both hardness with using of the nanofiltration as a pretreatment of RO, use of NF as a pretreatment of RO, the scaling of the RO membrane is reduced, and the recovery will be improved. In RO membranes, if we use only RO membranes without NF, the recovery will be 60. But with use of NF and separation of the sedimentation agent, calcium, magnesium, we can reach to recovery of 80 or 90%. Therefore, in some cases, NF used as a pretreatment of RO. In some cases, this coupling is mostly used for desalination and water treatment. First use MF, in some cases use UF. Use MF and UF as a pretreatment of RO, and after that, advanced oxidation process for removal of the remaining COs. Therefore, now if you check in the internet, you will see that this coupling mostly in recent years used, hollow fiber MF or UF is used as a pretreatment of RO, and after RO, we have a UV H2O2 as disinfection and as removal of the organic matters. Another problems of environmental is the greenhouse effect. You know, when we have a carbon dioxide or water in the air, some of the returned energy can capture it with carbon dioxide and cause to the increasing of the temperature. And this increasing of temperature can be many problems in ecosystem. One of the most application of the gas separation membranes is removal of carbon dioxide from flue gases. That yesterday we discussed about the application of gas separation. And gas separation is very, very important and have a good developing in recent years, and most governments in the world forced to companies that use the gas separation membranes from the flue gases. And now it is a very important research idea, converting of this captured carbon dioxide a useful materials, useful products. This is, can be used as a base of the carbon and oxygen for production of the other products. And now, in some companies, use this for production of methanol. Change carbon dioxide to monoxide and synthesize methanol from monoxide. And methanol then can be changed to the toluene, benzene, xylene. And benzene is, for example, the main matter of the drugs. We can prepare paracetamol, acetaminophen, and other from the benzene. Therefore, we have usually in management of carbon dioxide, separation of the carbon dioxide from the air, storage and capturing of them, and converting of the carbon dioxide to a good product. This slide shows the application of the membranes in dairy industry for fractionation of the milk materials. When we have a raw milk, usually we first separate the fat of the milk. For separation of the fat, we can use microfiltration membrane or centrifugal methods. And after separation, we can manage the scheme of this milk to the different materials with use of the UF, MF, or NF, or RO. Therefore, with the fractionation of the raw milk, we can produce different type of the products. And every of this, for example, way, again can be refractionated to many compounds. There are similar diagrams only for whey. And show that from the whey, for example, we can separate lactic acid. Lactic acid from the whey, and after that produce polylactic acid. Yesterday I said that the main biopolymer now used in the fabrication of membrane is polylactic acid that produced from lactic acid, and lactic acid from the milk and yogurt produced from the whey. Therefore, it is a very green biopolymer. The main application of the RO membranes is desalination, and the biggest membrane plant is related to the RO membranes, and the biggest RO plant is located in Israel. Israel. You know, Israel is very little country and is very hot and have the very water crisis. And the Red Sea, located in the Israel, have the very high saline concentration, about 70,000. I think the India Ocean is 30,000 ppm, the concentration of the salt. The Red Sea is two times. But Israel produce the sweet water from that Red Sea with desalination and use for agriculture, and is one of the biggest seller of orange and apple in the world. Low water, use the seawater, use desalination, and using agriculture, and is one of the biggest export of the orange to the world, and very delicious orange type, okay? This is show the good management of one country. The biggest one is located in Israel, and the second, third is located in the Persian Gulf. And one of the biggest one is in Iran, as a Fajr petrochemical reverse osmosis unit, is very big. This is one of the pump of these systems for transfer of the water from sea to the entrance of these units. And this is the pressure apply pumps that height is 3 meters. And this one pump you see in the tier, on the very big tier. Therefore, it's very big, and every year, 5,000 8-inch RO membranes is used in this company, and produce the distilled water for petrochemical industries. Iran have 50 big petrochemical industry and need the water for their process. And this Fajr RO unit produce the required water for these 50 big petrochemical companies. That petrochemicals produce different type of polymers, different type of chlorine, NaOH acid, and every chemicals produced in Iran. Before this RO, this is the destroyed membranes, that it is environmental problems. These companies say if you can give gift as a gift and come here and go and recover our everything. Every year, 5,000 ones, and the life of these modules is 5 years. That means this unit have 25,000 RO modules for product. Very big one. Before the RO membranes use cartridge filter for removal of particles. And there are many pressure vessels for cartridge filters. And use acid and anti-escalants in the feed of the RO for controlling the scaling. With use of anti-escalants, we reduce the possibility of the sedimentation. Another application of membrane in petrochemical in Iran is the use of the tubular polymeric membranes. In the production of the PVC polymer, one method is suspension method. We have an emulsion method and others. One of suspension method, that means the polymer particle produced in water as a solvent. In emulsion, we have another solvent for production of this. For concentration of the water and separation of the produced powder from the reactor, two devices is used. One is UF, tubular membranes, that they reduce 40% of water, and the remaining concentrated water go to the spray drying. This spray drying is very big, have a 30-meter height, and the heated concentrated of UF is sprayed from the top, and to reach to the bottom of here, all of water vapor, and powder reach to the bottom of this spray dryer. Therefore, UF can be, tubular UF can be used for separated of the particles from suspensions. Another application of the proton exchange membranes, naphthion and phlegmion, is in the production of chlor-alkali unit. This is the photograph of the Arvand petrochemical in Iran that use the NaCl as a feed and use the electrolyzers for electrolyze NaCl to NaOH, chlorine gas, and hydrogen gas. Okay? You know this reaction. With electrolyze of NaCl, we have a chlorine gas, H2 gas, and NaOH. The main of the purpose of this petrochemical is producing of chloride. But petrochemical need this chloride for reaction with ethylene, okay, to produce ethylene chloride. Ethylene chloride, okay, hydrogen. And this ethylene chloride produce PVC. As shown in this slide, you see Arvand, similar petrochemical. The main product of this petrochemical is PVC polymer. For production of the PVC, need chloride. This color reacts with ethylene, produce ethylene chloride, and this polymerized to PVC. But have the byproduct, hydrogen is used for heating, go to the heating system and combust with oxygen. And NaOH is, can be changed to the dry NaOH, or can be mixed NaOH with chlorine for production of the whitening solution. Whitening solution, what you say in India for whitening of clothes?
Washing soda.
Washing?
Soda.
Soda, washing soda, yes. With combination of this with chlorine gas, we have a wax solution. Therefore, have many products, but the main product PVC. And for production, electrolysis need to the exchange membrane, Nafion exchange membrane. And you see have a very big stacks. And for here, see, this is one electrode, and this is another electrode. Between two distance that is very, very low, you compare with the tube diameter, we have a one cation, and anion exchange membranes. Another most application of the RO and NF is in the cooling towers. Do you know what is cooling tower? These towers, maybe you see. What is the role of this cooling tower? In the production of the electricity, we have hot reactors and should be cooled with water. For cooling of the electrical production reactors, use the cool water, and cool water come contact with the reactor, and the warm and the hot water should be cooled for regain use. Okay, here is usually 30. Here is usually 80 centigrades. For reducing of this water that have a very big volume, use these cooling towers. In cooling towers is the simple mechanism. The water can pour from 50 meters, spray to the ground. And during this pass, some of the water can be evaporated, and when evaporate, give the energy of the water, and this evaporation cause to the reduction of the temperature. Therefore, this most very simple one, but in this type, we have some trays, some cascades for increasing of the water pass. And the height of this is lower. This is the 50 meters. This is usually 20 meters. But the simple, with evaporation, the temperature of water is reduced. But when we have evaporate, we know that the water evaporates as a pure one. No salts evaporate. Therefore, after a certain time, the remaining water will be very solid, because water evaporates and solid remain in water, and the conductivity of the solid can be increased and cause to the sedimentation and other problems. Therefore, we must reduce the desalinity, and in this case, usually use the small RO or NF plants. Small with you see for in this case have 18 pressure vessels. If each pressure vessels have 5 modules, we have 90 RO modules. These are simple, small plants, but in every production, electricity production, we have this RO units for desalination of this water. This is another RO unit that supply the cooling water of Tabriz petrochemicals. I have some project with these petrochemicals, and I share my experience. And another big consumption of the water is the production of steel iron factories, and need a lot of the waters for production, separation, and molding of the irons and steels. Therefore, need the water and pure water, because the presence of the calcium, magnesium can be a problem. And in Iran, there are also big RO units for producing of the steel factory water. Thank you. I share some this application. There are also many applications for other processes that I not discuss. Dr. Raka discussed about the application of the membrane in fuel cells, different type of fuel cells, and the storage of the hydrogen and other application. For example, per evaporation, I show Sulzer company for separation of the ethanol, separation of water from ethanol and reaching to absolute ethanol. That's used in Brazil most, and many our now membrane distillation is used in Persian Gulf for increase of the desalination recovery, because the most RO units in the world are located in the Persian Gulf, in Kuwait, Emirates, Qatar, Iran, because have the water crisis. India have a good humidity, but in Iran, Qatar, we have no humidity, and we all of the desert, no forest, no jungle. Therefore, the water is very important in Middle East area. Thank you. If any question?
Any question?
Production, which materials? We discussed before, for production of RO membranes, we use the polyester fabric as a supporting layer. We coat polysulfone on the non-fabric. That polysulfone in industrial scale dissolve in DMF. And after that, we coat TFC layer, that we have a two-step, MPD in water and TMC in hexane, okay? But we have some additives in TMC and MPD solution. In MPD solution, we add 3-ethylamine as a base, camphor sulfonic acid as a catalyst, and SDS, sodium dodecyl sulfate, as an increasing of the penetration of MPD to the membrane structure. And after production of the RO TFC, we coat with polyvinyl alcohol. And before polyvinyl alcohol, for removal of the excess MPD, we use acid citric solution and keep the membranes in sodium bisulfite disinfection. And many components can be used.
Sir, with respect to softening of the water, this MF plus RO, then UV is a best combination, you said. Similarly, for drinking water production and also for wastewater treatment, what is the best combination of these filtration membranes?
RO membranes completely remove everything and only pass the water and very little amount of the salts, okay? But for reducing of the fouling of the RO, we can use MF, UF, and NF before RO. MF is used for the particle separation. Maybe cartridge filter cannot be true, and we use MF for insurance of the no particle come to the RO. UF, if we use UF can remove some macromolecules, especially natural organic matters that there is in the seawater, and humic acid. This is the two problems in membrane fouling, because in the seawater we have a fish and another animals that produce some organic matters. Therefore, this, when go to the RO surface, can increase the organic fouling. Therefore, we can use the UF for separation of humic acid and natural organic matters. If we have a high hardness, we can use the NF before RO for removal of calcium, magnesium, sulfate, because these components can cause grossing of the calcium sulfate, calcium carbonate on the membrane surface that I will discuss after high T about the fouling. And after RO, we usually have no membrane. We have exceptional and use of MD, membrane distillation in the concentrate for more desalination. After RO, we usually have a disinfection with UV or chlorine gas. If we have a very low COD, that usually is very low, 2, 3, 5 ppm, we can use UV H2O for complete removal.
Okay, sir. Sir, you mentioned earlier about anti-scaling agents that is being used in case of the
anti-escalant. Okay.
Yes. So what sort of
what is anti-escalant? Huh?
No. What kind of materials or what kind of things that you used as anti-scalings? Because scaling, if you consider, whenever it's in salinated water, that is going to be there.
Yes.
Isn't it? But
which type of materials used as an anti-escalant agent?
Yes.
Okay.
Yes.
I will discuss in the tutorial.
Fouling.
I discuss.
Okay.
Yeah, okay. Different type of anti-escalant campaign, and the mechanism is interface with calcium. We have a ligand, soluble ligand. When complex with calcium, produce soluble calcium compound, and do not permit to reaction with sulfate for precipitation, carbonate for precipitation. Therefore, we have an interface between the calcium sulfate, calcium carbonate. Or another mechanism is that anti-escalant do not allow to attachment of the crystals together. We produce calcium sulfate that won't precipitate, but anti-escalant connect to these sediments and do not to agglomerate and produce big one, and are suspended in the feet. I will discuss in details.
I believe those all must be the MS pipes.
MS?
Pipes. I mean to say the pipes, those are being actually used. Sorry.
Echo, yes.
MS pipes are there, right, I believe?
MS?
Steel pipes.
Magnetic?
Material of construction you mentioned, sir. Mild steel pipes.
I do not understand.
Steel. This is iron
Steel,
pipes.
yes.
Iron pipes.
Iron pipes, what is it? Problems?
No, corrosion usually actually takes place in that.
Yes.
So I mean to say that we cannot use the steel pipes in that cases.
Yes.
But however, the MS pipes that we are actually using, that might be the cause, the corrosion then.
Yes, the corrosion is important in the membrane process. Before in the entrance of the RO membranes, because we have a high pressure, we use stainless steel. And after the RO, both in concentrate and permeate size, we use the HDPE, high density polyethylene tubes, and this reduces the corrosion. But in the feed side, we add, reduce the pH, because the reducing of the pH causes to the low sedimentation, and therefore we will have corrosion. But in industry, we have a different type of steels. Have a coat, say 360. That is the good resistance for corrosion. And we have a very acidic solution. We have a titanium-based corrosion tubes, resistant corrosion tubes. Therefore, we have a corrosion, and we can manage them. And this corrosion can go to the membrane surface and cause damage. Okay. Therefore, we have a 2 or 3 cartridge filter after the sand filter and carbon filter. In the RO units, we have a first sand filter, carbon filter for removing of the COD, very low amount of COD. After that, we use 2 or 3 cartridge, 10 micron, 5 micron, 1 micron. And 1 micron direct connected to the RO entrance, and 1 micron located between the pump and RO. Between the RO entrance and pump, we have 10 meter distance. But we have located one micron filter because maybe we have some corrosion in the pump on some tubes, and one iron particle is very dangerous for RO membrane. Therefore, we protect the membranes from the corrosion particles.
Sir, can you capture carbon dioxide from flue gases in membranes?
Yes.
But isn't that cause high fouling? Because flue gases have so much dust and other particles.
Fouling in the gas separation, I say we have not fouling. We have a plasticization and aging. Okay, and also the particles is dangerous for gas separation. And before the entrance of gas separation, we also have cartridge filters for removal of the particles. Yes, after 3-4 years, the gas separation can be plasticized, can be brittle, and should be replaced because especially carbon dioxide. Carbon dioxide reacts with the polymer change and change the chemistry and change the free volume of the membranes.
So, what kind of membranes do you use for carbon dioxide capture?
Mostly polyimide and polyimine wine. We know in absorption column that amine groups can good absorb the carbon dioxide. Therefore, a polymer with nitrogen groups have better carbon dioxide absorption. Therefore, polyimide, polyimide, polyimine have a good absorption of carbon dioxide, and most of the carbon dioxide gas separation membranes fabricated from these polymers.
Also, sir, suppose I want to do carbon sequestration, so I need to convert gaseous carbon dioxide into liquid.
Okay.
So, the membranes absorb carbon dioxide, right?
Yes.
So, how to convert into liquid? Is any specific desorption process?
Can change the carbon dioxide to liquid. Gas separation separates carbon dioxide from a flue gas and go to the storage tank. With compressing, we can change the carbon dioxide to liquid and solid one. We have a carbon dioxide solids that in the air produce the vapor. This is used with the compressor, not with membrane. Only membrane separate and they permeate, go to the tank and compress with compressor.
Sir, is the UV beneficial for like in wastewater treatment? The use of UV
Beneficial of
for wastewater treatment.
wastewater
Treatment.
P?
Treatment.
Treatment, yes?
Do
Beneficial of membranes?
Yeah. No, I mean the use of UV.
UV, why we use in the
Yeah.
UV have two effects. One, disinfection. With irradiation of UV to bacteria, the microorganism and bacteria will be deactive. You say deactive, it's the diet. UV cause to the dying of the bacteria. And the second one, UV can degrade. UV is a high energy and can degrade the organic matters to the little one. And if we have enough time, all of the carbon compound can be converted to carbon dioxide. That this is named degradation. Okay? Disinfection and degradation.
Okay. So it's like you can we can use it only like you just UV for wastewater treatment, or should we add another process
No, UV, yes, UV can be used alone.
alone? Yeah.
We have quartz tubes, and water comes from quartz tubes, and we have located UV lamps around these quartz tubes, because UV cannot pass from glass. We must use quartz. And when water go from 2 or 3 meters of UV lamps, during 2 seconds, 3 seconds, the bacteria can be deactive. Directly only use UV. Only use of the UV for degradation is not effective, not efficiency, because in this case we use another aiding compounds, such as hydrogen peroxide, such as sulfonoxide, sulfates, peroxides, some chemicals we can add that help the UV for degradation. Or we can use photocatalyst that can be active with UV. When our water have photocatalyst and go inside of the quartz, the photocatalyst react with UV and produce radicals and cause to the degradation.
Thank you.
Any other question? Okay. Let me, please join me in thanking Professor for his wonderful lectures. And thank you very much. It was the last lecture of this course. So next we have tutorial, but before that, please join me for tea in 312. Okay.